Hi, my name is Miwa, and I was a customer support engineer intern at the Tokyo office. I would like to share how I developed my model for energy pricing using the Pi system and Falkonry's pattern recognition machine learning. The model can be used by electricity consumers subjected to real-time energy pricing to identify when is the best time to consume or avoid electricity during the day. The model was created for energy prices in Kyushu, Japan. I collected data related to the Japanese energy market from various websites and imported them into the Pi system using the Pi connector for UFL and stored them in Pi points which can be viewed through AF attributes. Falkonry is fully integrated with Pi. Attribute data is fed in using Falkonry's integrator for the Pi system. Then Falkonry is trained by learning signal patterns that are associated with specific condition values provided by facts. Once a model is created, it assesses real-time data and returns the recognized condition value back into an AF attribute as a string value. The Falconry Pi integrator allows you to choose a database from a specified asset server and from an element template, select elements and attributes you want to train your model with. Historical facts that I use to train my model are the highest and lowest price points during the day, as well as periods of sudden jumps and fall in energy prices. I used event frames and analyses to generate these facts and used PyDataLink to export these facts as a CSV file to upload into Falconry. Once I trained my model, I used the model to generate real-time condition values. The colored bar is the assessment results generated by the model, where each color corresponds to a condition value which the model has identified from patterns associated with the input signals at that time point. I used Pi Process Book to overlay the corresponding energy price for the 7-day assessment produced for Kyushu, Japan. Here are all the maximum daily price points over the week. As you can see, the model has successfully labeled all these points as the daily max, signified by the red label, as well as other relatively high price points through the days. Similarly, the model was able to recognize the minimum daily price points throughout the week, signified by the blue label, as well as other relatively low troughs. Now zooming in a little closer to the first 2 days, it can be seen that the model has identified the sudden jumps and falls in energy price before the event occurs. Just a reminder that Falconry produces these assessments based on patterns from real-time data and has no information of future input values when the assessments are made. The Falconry service utilizes artificial intelligence, which makes creating models quite simple, with no programming and no knowledge of data science algorithms required. So how can consumers use these condition values that are being outputted back into Pi? For example, machinery could be set to pause operation if the string value returns daily max to avoid paying peak energy prices. Another example is that consumers can use information from condition values to determine whether it is cheaper to generate their own electricity or buy it from the grid. Thank you for listening.